In this video, we're going to discuss solving a system graphically. So I have my system right here, and I'll note that it's a linear, they're both linear because the x and the y's are both in the first power. And I'm going to solve this system. In this case, I'm going to solve it graphically. So that means I'm going to plot it, and I'm going to look for that point of intersection. Now, they're both lines, so I know that if they intersect, they're only going to intersect at that one spot because they're lines. The only alternative way that could happen is if they actually turn out to be the exact same line, and in that case, they intersect in infinite many areas. But that's not going to be the case here. So for this one, to solve it graphically, I'm going to first get it in my slope-intercept form. So I want it to look like my y equals mx plus b form. That will help me graph this. So let's go ahead and start with this one. I'm going to subtract x. Coming down here, I get this 2y equals negative x plus 8. Now I'm going to divide by 2 and divide by 2, and I end up with y equals negative 1/2 x plus 4. All right, so that is one of my lines. Let's try the next one, and let's do this in blue. So now for this one, I'm going to subtract 5x, I get a negative 2y equals negative 5x plus 4. Divide by a negative 2 to everything, and I end up with y equals 5/2 x minus 2. All right, so to solve this system graphically, again, notice what I did is I got it in that y equals mx plus b form, so I can pull out the slope and the y-intercept, and now I can use that to graph and find that intersection. So that's what we're going to do on the next slide. Okay, so here we go. Let's go ahead and draw my coordinate plane. Let's put some slashes in here, just because I'm not transferring a graph over. Trying to keep them as spread apart, nice and neat. Okay, so let's do the blue one first. In the blue, I see that I have a y-intercept of negative 2, so I'm going to make my point right there. Now I'm going to go up 5, 1, 2, 3, 4, 5, and then I'm going to run in the positive direction 2. So I make my point, draw my line, and voila. All right, so the next one I'm going to do, and it is nice to label these lines, so y equals 5/2 x minus 2. So the next one, I am going to do this one. I'm going to start at 4. So 1, 2, 3, 4, 4 on the y-axis. I'm going to go down 1 and over 2. Ooh, this is nice because they end up being the exact same point that I had made to graph them. So now I'm going to look at this point of intersection, and I see that they intersect right there at 2, 3. So the point of intersection is 2, 3. And that's going to be my answer. So if I had to, get a little fancy, I'd say, okay, my solution set is going to be 2, 3. So I need to note that, again, it's going to be a point that they intersect at. So I can't just have x equals 2 or y equals 3. It's both that 2, 3 for my solution. Okay, so the next two slides, what we're going to do is I'm going to solve the exact same linear equations, but two different methods. So this one I'm going to solve by substitution. So what it means is that I'm going to solve for a particular variable, and then I'm going to plug all of that in to the next equation. Now, I could solve for any variable, but what I think is the easiest one to solve for is this x. So what I'm going to do is I'm going to subtract 2y, and I end up with x equals 8 minus 2y. Or I could have wrote it as negative 2y plus 8. Either way is acceptable. So now what I'm going to do is I'm going to take all of this and I'm going to plug it on in for x. So what I end up with, and let me change my colors around here, 5 parentheses 8 minus 2y, go back to black, minus 2y equals 4. So let's solve. So now I have 40 minus 10y minus 2y equals 4. That's going to give me a 40 minus 12y equals 4. And then I subtract 40 on both sides. And I'm going to end up with negative 12y equals negative 36. So then when I divide by negative 12 and divide by negative 12, y is going to equal 3. So then I'm going to take that, I'm going to say, okay, well, if I know y equals 3, let's figure out what x is. So if I plug 3 right in here for y, I get 8 minus 2 times 3, which is 8 minus 6, which will end up giving me x equals 2. So I see my solution again is 2, 3. So I did the exact same equation, only this time I did it by substitution to find that point of intersection. So I really want to make sure that you can see how all of these methods go together. One last one. In this one, we're actually going to solve by the elimination method. This is otherwise known as the addition method because ultimately what you're doing is you're adding both of these together. Now this one is really nice because it's already set up that when I add these two equations together, the y's will cancel out. And when they cancel out, I get this 6x equals 12. And when I divide by 6 on both sides, I get x equals 2, which I should already know that to be true because I already solved it graphically and through substitution. So now let's figure out the next one. So 2 plus 2y equals 8. And I just want you to note, I could put in that x equals 2 in for the first equation for right here or in for here. It doesn't matter. I'll get the exact same y. I chose this one just because I thought it would be a little easier. So if I subtract 2 on both sides, I get 2y equals 6, divide by 2, and I get y equals 3. So in conclusion, I see I get the exact same solution, 2, 3. So just to kind of recap, we see that we have the system of linear equations. We're solving the system, which, understand your goal, means that you're trying to find that point of intersection. I showed how this could be done graphically. I showed how we could do it through substitution, and then I gave you an example of how you can do this through elimination. 3 methods to achieve the exact same goal.